Hi guys, let's go ahead and get started with your extra credit activity for those of you that are completing that. We're going to open up desmos.com and we are going to click where it says open graphing calculator, and we are going to get started right here. Now on the screen, remember that you can zoom in, you can zoom out if you want to see more of the graph. And we are going to start by doing step number 1, what says to type in your parent function. So go ahead and tap your screen right where it has number 1 and type in y equals x so we can see what that graph looks like. Now that graph is an increasing line, so an increasing linear graph. So on line number 1 there, when it says what does your graph look like, it looks like a straight line, an increasing straight line. Now the next one says, step 2 says, enter the first equation into the next line. So go ahead and tap where it says 2. It's going to open up a new line for us. And right here, we're going to type in y equals negative x. That's our next equation. Now, what you're asked to do is to compare these. How did the first line differ from the second line? Well, this made it a negative graph. So a negative graph is decreasing. It's still a line. The shape did not change. The y-intercept did not change. It just opens downward now. So from left to right, this is a decreasing line. Now on line number 2, that's something that you should write. The graph is going down, it's decreasing, any of that information. This is in your own words describing what you see. Now you have 2 options at this point. You can delete this information, okay, and then type in your next new equation, which is y equals 1/5 x, so 1 divided by 5 x. Okay, that's one option. And let's look at that one before we do the next one. So here I'm comparing the 2 lines. If y equals x is my parent function, and I can turn that on or turn that off. So if I'm looking at y equals x, and now I have y equals 1/5 x, what do you notice about the green graph compared to the red graph? Well, it's actually flatter, so it's closer to the x-axis. It still goes through the y-intercept 0, 0, or 0, the origin 0, 0, but it still has the same y-intercept. It's just flatter now. All right, so let's go ahead and enter the next equation. So this time I'm not going to delete that. I'm just going to click where that little squiggly line is that's green, and it'll turn it off. And right underneath it, I'm going to type in y equals our next equation, which is x plus 6 in the parentheses. Okay, so I'm sorry, it's x minus 6. So x minus 6 in parentheses. Okay, when I look at this graph here, to me, it looks like it shifted right. So it's no longer at y equals 0, but it is at y equals negative 6 for the y-intercept. But it looks like it shifted right so that x is at 6. So whether you see that this graph shifted right or shifted down with linear, they're both going to be correct. But I look at it, since it's in the parentheses, it is actually our h value. And the h value does opposite of what we see. So instead of being at negative 6, it moves right to positive 6. So this one here, you can say that it shifted right 6 units. You can say that the y-intercept is at negative 6. If you see that it shifted down 6 units, you can say that as well. Move down 6 units, whichever wording that you choose that tells me that you're describing this in your own words, in your own understanding of that. All right, so I'm going to go ahead and turn that one off, and let's do our next equation. Our next equation is y equals x minus 3. Now on this one, this doesn't have parentheses. It's still linear, so all of these graphs should remain linear. The shape should not change. Okay, and on this one here, this one is shifting down 3 units, so the new y-intercept is at y equals negative 3. It also has an x-intercept at x equals positive 3. Okay, all right, and then our last one that we're going to look at is y equals negative 4x. Okay, and then, oops. Oh, I forgot the y. So y equals negative 4x. And just looking at that, so pay attention as you type it in. So let me go back. If I type in y equals negative 4x, I noticed there that it actually still has the same y-intercept of y equals 0. I noticed that it's decreasing, and I noticed that it looks steeper, which means it looks a little taller this time. It's not flatter. This one is actually taller or skinnier. Okay? Then I'm going to put in plus 5. And then I noticed that the y-intercept moves up to positive 5. Okay? So negative 4x plus 5 moves up 5, looks skinnier or looks taller, and it's opening downward. Okay, so it's a negative graph. Now let me show you some of the notes that I wrote down on my paper. Okay, so these were my descriptions on how I filled out for y equals x. You'd want to fill out that according to your words, however you see it happening. Then do the same thing for y equals absolute value of x, y equals x squared, y equals square root of x, and then see if you can find some differences. How does the negative sign transform the graph? How does a transform the graph? How about the h value or the k value? Do you see any patterns? All right, so your next one here, I'm going to go ahead and delete all of these. Actually, I wanted to show you that. What if I turn them all on? What does that look like? So we had y equals negative 4x plus 5. So you can actually see all of the graphs here that you typed in when you leave them on the screen so you can see what they're doing. But when you're writing their comparison, you're only going to want to see one at a time. And you always want the parent function, the first one showing. All right, so let's go ahead and get rid of those and get you started for yours that you're going to start with. So you're going to type in y equals absolute value of x on the first line and then follow along with the next ones.